It is called Torselian vacuum. Torselian vacuum. It has pressure equal 0. Look at the point X and the point Y. These 2 points, X outside the container and the point Y inside the container. The pressure at Y will be the pressure at X. Py will be equal to Pxy because they are existed at the same horizontal plane. So the pressure inside the container will be rho GH. However, the pressure outside the container will be the atmospheric air pressure. So the air pressure can be calculated using the Torselian parameter or metric parameter using the liquid. Mercury, which has a density equal 13,600 kilogram per cubic meter, is the heaviest substance or very heavy liquid, multiply G, which is 9.8, and the depth, which is H, that's equal 0.76 meters. So the pressure, or atmospheric air pressure, depending on the density of the mercury, the density of the mercury would be equal 1,305.95 kilogram per meter cube. The depth will be equal 0.76 meter. The acceleration due to gravity will be 9.8 meter per second squared. If you know the atmospheric air pressure or the pressure, that's all equal rho G H, which is equal 13595 by 9.8 by 0.76. It will be the atmospheric air pressure with a constant value, which is 1.013 by 10 power 5. Its newtons will be, its units will be Newton per meter square. So the atmospheric air pressure, we'll make a comparison between the different units of the pressure. The atmospheric air pressure will be equal 1.0113 by 10 power 5. This value has a unit Newton per meter square. However, the atmospheric air pressure will be considered as 1 bar, which is equal 76 centimeter Hg, or 760 millimeter Hg. The value of millimeter Hg can be replaced by the word torque, referring to Torselian, which is a scientist who discovered, or he made a metric parameter. Okay? The value of 1.013 by 10 power 5 Newton per meter square can be symbolized by replacing Newton per meter square by the word Pascal. Okay? And the word 10 power 5 Newton per meter square, or 10 power 5 Pascal, can be replaced by the word bar. So the atmospheric air pressure equal 1.013 bar. Okay, the last point in the applications of the pressure, which is the fourth one, is the manometer for trapped gas. If we have a container which has a gas and connected with U-shaped tube, if the mercury in both sides is existed at the same horizontal plane, so the pressure inside equals the pressure outside. P1 equal P2. At this point, the pressure in point 2 is the atmospheric air pressure. So the gas has atmospheric air pressure too. So there is equilibrium between them. But if we found that the pressure or the height of the mercury in the connected plane or the connected tube, we have two branches. It is a free branch, and this is a branch which is connected to the gas. Look at the separating surface between the mercury in both sides. At point A and at point B, the pressure will be equal. So the pressure at A equal the pressure at B. The pressure at A will be equal atmospheric air pressure. But the pressure at the point B will be equal PA minus H. How to be? How to be? Look at the atmospheric air pressure. It is stronger than the pressure inside the gas. The pressure inside the gas. So the gas can be compressed under the influence of the atmospheric air pressure. So the pressure of the gas will be less than the atmospheric air pressure. Why difference? H. What is the H? It is the height of the mercury at the connected vessel. So the H at connected branch, the connected branch to the liquid, so the pressure of the gas will be equal the atmospheric air pressure minus the height. From this formula we can get Bg minus PA, or delta P, which is Pg minus PA will be equal negative H. If we have another container which has a trapped gas, but in this case, the height of the mercury in the free branch will be greater than the height of the mercury in the connected branch by the difference H. At this point, Px or P gas will be equal the P liquid. B gas equal the P liquid, which is Pa plus rho GH. So the B gas will be the atmospheric air pressure plus the height of the mercury. Okay, and Pg minus Pa is the pressure of the gas minus the pressure of the atmospheric air pressure will be equal H. This value is marked by delta P. At this point, we have finished all points that concern to the pressure, and in the coming session, we will take the Pascal's principle. Till we meet again. Bye-bye.